so you can see my screen. Okay. Okay. If you see this, the screen here is that I'm going to show to you on the student feedback. So we have done the weekly feedback for week 1 and week 2. So week 1 and week 2. So let's see how many students did reply on the feedback. So roughly about week 1 is 35 students and week 2 is 30 students. So I'm not sure what happened to the 5 more students. In week 2, they didn't do the feedback, and why. Okay. Why this feedback is important is actually for reflection. So I want to know, did you really answer the question that I gave to you, the task that I gave to you in class, weekly class? Because most of the contents are asynchronous. So if you do not answer the feedback, then I wouldn't know if you did go through my class. So it's important that all of students, please make sure that you answer the feedback according to the deadline. Okay. And the deadline is mostly, I'm giving you 1 week to complete the deadline for that week task. Okay. So I'm not going to extend it. So means that those who didn't respond means that 5 more students who didn't respond means that they were after deadline means that they cannot actually feedback anymore. So unfortunately, that is not considered as attendance. Okay. As I mentioned in the ULearn, okay, the response for feedback is important because that will be considered as attendance, right? If you don't key in the feedback, then you wouldn't get the attendance. Okay, and do not say that you do not know this or blah blah blah. I do not know, doctor. I need to do the feedback form. No. If you say you don't know, then means that you didn't go through the instruction in the ULearn, weekly ULearn. Okay, there is a full instruction there. Okay, if you did read carefully, then you actually will complete the feedback form accordingly. Okay, all right. So let's see to the feedback form week 1. Week 1. Okay, week 1. Week 1. Okay, week 1. Okay, show responses, 35 students responded. So if you see here, okay, so Pun Chenwei, okay, I explained that 3 to 5 sentence. So for the new weekly feedback is that I see minimum 5 paragraph. So 5 paragraph minimum. Okay, for week 1, it's okay if you write a very short form like this. Short form because it's just an introduction. So at least explain what you actually understood. Okay, for example, sorry, but I'm going to give you an example that poor how not to write a feedback, or example of a poor feedback. So like this, very motivating class. Okay, my question was describe the content of the class. Point form, minimum 3 to 5 sentences. Your sentence is only 1 and not related to class. So if I will give you marks on this, you get 0 for this type of feedback. Okay, so please write in a full sentence. Okay, full sentence. Okay, like this, only 2 sentences. I ask minimum 3 sentences. Okay, so let's go. And by the way, I have uploaded this. If you refer back to what you have written, okay, and you will see that, oh, did you really follow my instruction? Okay, example this one, no, not following my instruction. Okay, and if you I actually have uploaded in the ULearn, okay, so that student can actually look at your friends' feedback. Okay, take an example of how other students did their feedback. So example, week 1. Okay, week 1. Week 1. Okay, week 1. Right, I have uploaded here. If you see here, remember, you can see here there's that week 1 feedback response. This one I just uploaded. Okay, you click on that. Okay, Okay, there are two files under here. So it's the feedback from week 1 and also the week 1 non-respondent. So I'm going to also upload who didn't actually responded. Okay, so that you take note. So this one is the example of response. So you can go through. Okay, this one is, so hopefully for this week, make sure that student write out a good feedback. And another one is that the non-respondent. The non-respondent here, I'm not sure if these 5 students are actually in my section. Any student, if are this student in my section? Anyone can respond in the chat? Okay, Surya, I'm not sure. Kak Ed, Muhammad Malik Faizal, Muhammad Haziq Asnizan, Fu Huishan. Okay, I will wait until this week 3. If their name is not still in the feedback, I'm going to remove them from my section, so that easy for me to actually do some summary on student response. Okay, so just take note on that. If you know them, inform them that please just remove yourself from section 1, section 2 you learn. Okay, and let me just go to week the feedback for week 2. Okay, week 2 is interesting because student mostly you have the task on chapter 1, introduction to mechatronics. So you learn about the 3 main block diagram. Okay, what was the block diagram that you have learned on the mechatronic system? Can you write in the chat? What are the 3 block diagram for a mechatronic system? Write in the chat what are the 3. You can write there 1, 2, 3. Okay, 1 is what, 2 is what, 3 is what. Okay, so let's see what's the answer. Okay, write in 1 sentence lah. Okay, example Lao measurement system is one of it. So can you just write in 1 measurement system, comma, what is it? See? Alright. So let's go. Yang lain? How about the rest? Measurement system. No, directly write in. Okay. 1 exercise 2. Example, look at my example. Very okay. Okay, Lao. Okay, good. Like that. Okay. The rest, how about the rest? Don't look at your friend answer and don't copy paste. Alright. Okay, so most of you still remember what was the last week topic. So you have the 3 main system, which is the measurement system, first one, and the second one you have the actuation system, and the third one is the control system. So we are going to go through all this topic according to the sequence. So which is for today is that on the measurement system, on sensor and transducer. Okay, very good. How about the rest? I think only like less than 10 a reply. How about the rest? Please go to the chat. Okay, click on the chat icon. Write out what are the 3 main system block that we have in the mechatronic system. Okay, write it out. Okay, I will consider this as the active attendance. Okay, because I can actually save this chat later on and to check your attendance. Alright, measurement system, actuation system, controller. Alright, okay, most of you can still remember. So let's look at the comment. Okay, your students feedback. Okay, it's interesting to see student comment because for week 2 we have a lot of tasks. Not feedback. For the feedback is lots of additional question that I have added into the week to the feedback. So the first question that I have asked, okay, is based on slide 29 and appendix A and B, what are the process in the front-end semiconductor industry? List the process in sequence. So actually, I have given to you a slide 29, and I have given to you also the appendix A and B. Okay, so it's actually detailed inside the appendix A and B. So I just asked what are the process in the front end semiconductor. So just list out what are the process in sequence. So I didn't ask you to explain about what are, for example, each of the process, what does it do? For example, die attach. Okay, what does die attach mean? No, okay, I didn't ask you to explain it. I just asked you to list it out. So remember, in a final exam question or midterm question, read carefully the question. So if it asks you to list the process, then you just list it out. If it asks you to explain and elaborate on a process, then you need to explain, not only explain in terms of sentences but and paragraph, but also explain it with a diagram. Okay, draw out the diagram. Okay, and so that is going to add because normally for the lecturers solution manual, we have the diagram for added marks. So if student draw the diagram and so on, you get marks. Of course, because now it's online exam, so cannot copy paste lah. Okay, draw it on your own, right? Draw it using your hand and then draw it on a piece of paper. Okay, okay, and so the question was, okay, ni Amirul Hakim jawab, okay, clean room protocol, photo masking, etching, blah 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 blah. Okay, front end semiconductor. Okay, okay, boleh lah ni. In sequence, okay, but clean room is actually not a process. Clean room is the environment. So you can actually, if you look at appendix A and B, you can actually take out the process. Okay, this one, okay, good, at least have effort. Okay, based on slide 39, what are the process of back end in semiconductor? So back end is different. It's in example. Okay, front end semiconductor is example in Infineon. We have Infineon Penang. Okay, Infineon Kedah there. Okay, Kulim over there. They have the front end semiconductor, means that on the wafer process. If you have watched the video, wafer is actually the circle part, which is on there we have all the die. And for the back end process is something that we have in the Malacca branch, which is the Infineon Malacca. They are on the back end semiconductor, means that on assembly. So they take the die there, wafer from the front end, and then in the Infineon back end, they are going to cut the wafer process. So if you see here is that, okay, this is good, okay, Amirul. So example is that wafer testing first, we're checking the wafer, if which one is good. Okay, we have all lots of die on a wafer. Okay, mounting, dicing the process, bonding plasma, die attach, this is, we call it die attach. And then wire bonding, quality control, next is go to the back of line. Okay, we call it as we have the under back end, we have the front of line and end of line. So under this top one, the one I highlight here is the front of line in the back end process, and the another part is a end of line in the back end process. Means that in Infineon they have two different environment. One is the one that you need to cover all wearing the overall, the dust overall, white everything. Okay, like you see, like the Teletubby basically. So I was working at Infineon last time for 1 year on the wire bonding process. So to enter the front of line here, okay, wire bonding process is over here. Front of line, you need to wear the suit, the full suits. Okay, and it's kind of hot because well, I'm wearing tudung and so on, and so it's very hot. And okay, so that's one thing. And then third question is that based on slide 39, what is the application of ball screw in die bond process? So why I ask this is that I'm going to actually, I want student to actually think, okay, what is ball screw? Ball screw is actually a type of actuator, which is mechanical actuator. So what are the use of ball screw in this die bond process? So if this student, Amirul, answer, its function as linear actuator that translate rotary motion to linear motion. Yes, correct. this is super correct. Okay, so direct blah blah blah. Okay, so at least did he know or he understood what was the video about or what was the application about? Okay, describe what we have learned. So I have learned a lot, blah blah. Okay, very good. So example like Miracle Hakim feedback is very good. Okay, not a good example. Okay, but I'm going to show to student not because this is reason why. Okay, example this second comment. Process in die bond. Process in front end semiconductor die bond. One process only. Did you actually read or view the appendix A and B? Then did you actually view the video? I don't think so. Or you are sorry to say, but you are too lazy to actually write out. So this is actually reflect first impression. My impression on student. Okay, if you write this short and so do not do this. Okay, if you write this in exam, you get 0 marks. Sorry, you get 0 marks. Okay, not a good example. So I like this one, like T Kian. Okay, very good. Okay, lots. The answer is long, and then you means that I know that you understood what you have go through the whole instruction in you learn. Okay, for example like this. Oh, very long. Okay, very good. Long. Okay, assembly and then heavy duty ball. This is detail. Okay, and we do what have learned. So I would say that from student feedback, I would know which student actually can score an A for this subject. Okay, I already can estimate who can get an A. Okay, so well, you can go through this. I have uploaded in the ULearn also under week 2. You can go through the feedback example. So this week 3, I hope that when I ask student to give the feedback, please make it detailed. Make it a detailed comment. Alright, so that one is on the feedback. So next is that I want to comment on the assignment. Okay, the group assignment. Okay, remember. Okay. Okay, do you remember that we have the group assignment? Remember we have the group assignment last week. Okay, tutorial session based on published journal paper. I have uploaded journal paper from J1 until J12. Each group are required to determine the following parameter, which represent the mechanical control system, where it comprises of the measurement system and actuator system. Okay. Explain your answer using a block diagram. So need to use a block diagram to explain it, and each block need to be elaborated accordingly. Okay, so each group compulsory to submit blah blah blah. Okay, each group already submitted 12 group according to deadline. Okay, very good. Okay, full instruction in ULearn. So anyway, this is example of what you should come out with the block, but what you need to do was to actually go through the journal paper. Okay, and then determine which one is the actuation system, which one is the measurement system, and also which one is the amplifier. If you read from the journal, if you can determine which one is the signal conditioning, and then if there is any control involved in the journal, okay, reading. So I'm going to show to you example. Not example. I'm going to show to you student answer, and I'm going to comment one by one. So group 1. Okay, group 1. Azam Anas, Lutfi dengan Luqman. Okay, so okay, because the question was simple to actually draw out, determine which one was for the block diagram, for the actuation system, for the measurement system, and controller. So the student actually got the paper on the micromotor, induction micromotor. So they actually determine which one is the actuation system. So rotor, electric stator, and so on. Measurement system, okay, using optical displacement, high speed charge control, okay. well, acceptable. And then controller architecture here is that using the electrical means that I think it's not using any I'm not sure if you read there is any controller, but well, I want to comment on the block diagram itself. Okay, if you see this block diagram, okay, on the left side, and you compare to the block diagram that I show in the on the slide, on the slide here, is it the same block diagram? Okay, question. Can you answer in the chat? My question is that, is the block diagram on the left is the same with the right? Same, yes or no?
No, Doctor.
Yes or no? Yes or no? Okay. Okay. A few are answering yes. Few are answering no. Right? Lots of no. Then yes. Who, the other student? Only 9 students answering. Where's the rest of the student? Yes, no, yes, no. Which one? What do you think? Okay. I think most of you no. No is more than yes, So my answer, what do you think? My answer is, okay, if you see in this block, you see that I have the input reference, okay? I have the output, input, okay? That's the important part. And then you are going to have the arrow in, arrow out, output. Then you have the actuation system in the middle. And you have the feedback from the output. You are going to feed it back to the error. And you have the measurement system. So, and you have the error point here. So error is, if you see here, you have the plus and minus, right? The plus and minus means that E is actually input minus output. Okay, so there's a reason why there's a plus and minus there. Okay, and then from this error is going to go into the controller. So we go back to this block. Okay, we go back to this block. Okay, so we have the input reference, output, output, yes. How about the error? There's no plus minus. So if you do not put plus minus, that it is assumed that it's actually plus and plus, because this is actually a summation point. Okay, summation point. If there is no indication of plus and minus, then automatically it's going to be a summation of plus and plus. Okay, so make sure that you label it plus and minus accordingly. And the third one is that my answer is that there are two things that is not correct with this block. First is that it doesn't represent this block, means that how the student actually come up with the block diagram. I didn't actually I don't know, I give an example of this block. Okay, I expect that students are going to come up with this exact block. Okay, means that the sequence is like this. So it means that what I expect is that you have the controller here, you have the actuator here, actuation system there, and then you have the measurement system. So you need to have the input going in, output, okay, you have the summation point here, plus minus, and then you have this one, the feedback. So I expect, okay, and even towards the end of year 4 later on, if you're learning about controller, control 1 subject or control 2 subject, you're going to learn that you need to come up with this type of block diagram. Okay, do not come up with something like this. Okay, because this is not how control block is being drawn. Okay, so I would say just arrange it so that you can get this type of block diagram on the right. And one more thing, I think you are second year student already, and then you have most of you are from diploma student, or you are from matriculasi or from STPM. Okay, I'm sure you have used Microsoft Word before. You can actually this page here. You know that this page is in portrait mode, so you can actually edit the layout. This layout is in portrait. You see the orientation portrait. So if I understood why this student come up with this block because not enough space, but not enough space is not the excuse that student give. Okay, because you can actually rotate it to become a landscape. So you have a better, a larger area to actually you have a larger area to draw out. You have, sorry, example is already like yes, right? So you have a larger area to draw out. Okay, so for the this is comment on the assignment. Okay, because not only this group 1 is doing the same mistake, but a lot of group is doing the mistake, the similar mistake. So don't do this mistake. So this is group 1. Okay, group 2, let's see group 2. Group 2, okay, group 2. Okay, group 2, Muhammad Omar, Koh, and Muhammad Irshad. Okay, blah blah blah. Okay, the student got the electrostatic actuator journal. Okay, actually this is my journal, my paper, so I know the details. So let's see what's the block diagram. So block diagram is that right here electrostatic actuator. Okay, then you have the capacitor displacement sensor. Okay, input output signal A to D, output. Okay, PID controller, which is plus the non-inertial control. So well, there is some mistake. Okay, the block diagram looks okay to me. Okay, it's similar to what I have written in the slide, but what is missing? What is missing? What do you think is missing? Right there in the chat. Anything wrong with this block diagram? Right in the chat. Anything wrong? Or you can unmute, if you want to answer. Elaborate. Elaborate. Okay, there's some. Okay, but let's see what's the question. The answer is the sign. Okay, the sign. You have the plus. What else is wrong? Minus, plus minus. What else is wrong also here? What else? What do you think? The labeling. Labeling of what? The input reference. We have the output. We have the controller. We have the signal conditioning. We have the actuation. We have the measurement system. Okay? There are two more mistakes in this block. What is it? The feedback block. Okay? The feedback block from here. It needs to be connected to the summation point here. Okay, not this. Wrong. Okay, it need to connect to this summation point. Remember, this is a summation point. Then this is called the error value because plus minus. And then another one that is missing here is the labeling of the input reference. Okay, remember that. Input reference can be an input signal or you put a reference that you want to control. For the case of this journal is that the displacement reference. So you want to control it for 10 micrometer and so on. Okay, very good. So lots of you detected that the minus signal. Okay, and then the impact, the feedback loop is also incorrect. The arrow lah. Alright. So labeling ada 3. So let's see if they explain about this one. So because there are some commented that elaboration, Nurul Syafiqah comment elaboration. So okay, because this block diagram is general lah. Okay, very simple. But let's see what did they explain in the next page. So explain about control architecture, linearizer, blah blah, actuation. Okay, and only two for the group. Explain, elaborate on control architecture and actuator. How about the what happened to the measurement system? Okay, tak ada, no elaboration. Okay, need to elaborate on that. Okay, right? So that one is group 2. Group 3. Group 3. Let's see. Hamizan, Nurul Syafiqah, Mama Afif. Okay, they get the paper on the robotic hand system. Okay, so let's see. Okay, very good. Okay, let's see if it's correct. Okay, we have the block diagram. Anything wrong with this block diagram? Can you answer in the chat? Yes, no. Anything wrong? Anything wrong with the block diagram? I have detected one problem. Right there in the chat, what is missing in the block diagram? Okay, CVS minus sign. Is that minus sign? Okay, everybody detect that. Okay, so missing the minus sign here. Okay, you have the plus, then you have minus. So missing this one. Okay, the rest looks good. Okay, so we have the actuation system. You have the whole thing down here is the measurement system. Then we have this one is the controller. Okay, so looks good to me. So this one is up to now, I think group 3 the best so far on the explanation. So they explain directly in the block diagram. Okay, like I said okay, in the learn the task, I said that it's not compulsory to actually use Word Word to do your assignment, because I know if you would use Word, what happens that you're going to do is similar to what happened to group 1, no space. So that's why I said, I told student, you can use handwriting, write out like this group, write it out, okay, then scan it, because later when you submit in your midterm exam or in your final exam, you're going to do similar like this. You're going to write it out handwritten, tak boleh copy paste. Copy paste, take it out, copy paste from into words and then submit that word in Word file. Okay, means that automatically we know it's copy paste lah. So what you need to do is that you need to write out similar like this. Okay, write it out and scan. Think by now most of you know how to scan using apps, handphone apps. So should it be a problem? Okay, very good. This group. Okay, group 3. Okay, group 4. Group 4. Okay, Mama Aiman, Mama Afiq, Haziq Imran, Okay. Why? Okay. Okay. This group is have the journal mobile. Why I'm actually not laughing lah. But when I look at this, I remember group 1 block diagram. It looks similar. So I'm not sure if group 1 and this group 4 they discuss about how to draw it out, or one of the group write it out and then, okay, can I look at your blog and then I want to copy it. I'm not sure, but it looks similar. So please do not draw like this. Okay, I'm not judging, but this is my first impression when I look at student answer, because as lecturer we always remember when we mark student answer sheet, what happens that this look familiar. I think I already marked this before. Okay, so don't play with the lecturer lah. We can remember. So like this, what's wrong with this block? Okay, one thing is the arrangement is in portrait, so you need to put it in the landscape. And one thing, what happened, okay, you have the plus minus, okay, good, you have the plus minus inside here. The thing is about when you draw a block diagram, always remember that the arrow need to be connected from one point to another point. So make sure it's connected. Connected, this is not connected, not connected, not connected. Okay? And then don't draw a block diagram, fancy block like this, blue, another shading semua. No need. Just a simple square with no background color. Okay? If you look at a control book, okay, you can actually always Google out control block diagram. You don't find any block diagram drawn like this. Okay, it's very simple, the empty box. Okay, so make sure do not do fancy. When we do engineering, simple is better. Okay, so only this one. Okay, actuation system. Okay, actuation system, you have the signal conditioning. Okay, good. Actuator, you have the motor, motor, sensor. Sensor no need, not inside here. Sensor is inside here. Arduino, serial motor. This is under measurement system. Line following. Oh, sorry, this is wrong. Actually, your actuator is only DC motor. Okay, why I can know this? Because this is my student journal paper, so I know. So, wrong, So, this group, make sure check again what you understand about actuator. Okay, what is measurement system? Measurement system is all about the sensors. Sensors that's going to read the actuator. So you have a DC motor means that it's going to read the rotation. So you need to have the sensor. Okay, sensor means that the encoder, one thing, and then you have the sensor to detect the obstacle. The obstacle. So you have the ultrasonic sensor, and then you have the laser finder. No. Laser finder is not in the journal. It's just explained there, but it's not in the journal. Okay, you have only ultrasonic sensor and infrared sensor, right? 2. Controller here is that using the mechanism cases, mechanism for wheel, ball wheel. Okay, all of this is actually under actuator. Is what we call, everything here is what we call as the mechanical actuator. Later on in chapter, I think chapter 6 or 7, you're going to learn about there are 3 types of actuator: mechanical actuator, electrical actuator, and pneumatic and hydraulic actuator. So all of this is put under mechanical actuator. So it's okay because we haven't reached up to that topic yet, but at least you learn starting from now that this is not the correct architecture. So the controller is actually the one the signal for this case is that there's no control involved, but it's just a closed loop. Okay, so it's okay, don't worry. This is just my comment to student. Group 5. Okay, group 5, Afza, Nur Najah, and Teikian. Okay, let's look at what the topic, closed loop, blah 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 blah. Okay, this one. Oh, okay, this one. Oh, this is not good. I do not separate it into 2 pages like this. Okay, so like I said just now, okay, it's easy to actually copy paste from journal, copy paste everything, put it into your Word file because it's easy to do that. But I like what group 3 just now did. The one that they write handwritten, draw out, because when they do that means that they transfer the knowledge that they read from the journal paper. They transfer okay, in the actuator system you have the electrostatic actuator, the actuator, and blah 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 and so on. So they read it out again. So that is what that is actually how you learn. There are so many ways to learn. One way is that by listening to me. Okay, you listen to me, you learn. Second one is that by reading. By reading, you also learn. And third one is that after you listen to me, you write it out on a piece of paper. So if you take a piece of paper, for example, like today, I'm giving a lecture, kan? So take out a piece of paper and a pen. I do not know how students nowadays study, but last time when I was doing undergraduate or even master, even during my undergraduate, we don't have these notes PowerPoint notes semua tak ada. There's no notes. What the lecturer do is that write on the whiteboard, blah, 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 very fast. And then what we need to do is that, mostly me lah, but my friends is not writing it out. Okay, what I do is that, when the lecturer write it, I will write very fast. Okay, you need to have a short form, write very fast. And then go back home, look at the notes, and then simplify again or make it into a beautiful notes for your reference. So that is how you study. If you don't write it out, for example, if my class right now, you just listen to me, oh, very boring, and so on. So end up, by the end of today's class, what have you learned? You will learn that you will ask this student who did not write out the notes. Later, they will ask, Doctor, can you share to us the video recording? Okay? Because, why? They didn't jot down. So they want the recording very fast. But the thing is that if I give you the recording, will you actually come up with your own notes? I don't think so. Okay, so this is where you need to have the technique of studying. The technique to study. You can ask your friend. I think lots of you guys are from STPM, from Matrix. Good student actually come up with their own notes. Okay, come up with your own notes because why? You will know later on when you have your own notes ready. It's very easy for you to do the revision. Okay, means that not last minute. You have your own notes. You just revise again, understand it again. Okay, in compared to those who do not have notes, but you have the notes from my class lecture PowerPoint slide ni. PowerPoint slide pun normally I will ask student, oh, okay, in my class, what need compulsory to print this out? In class, please jot down. Okay. If I do not give that specific instruction, what happens that the student won't print it out. And then what happens that they're going to bring their handphone, very small handphone, and then look at the slide. Wow, I think later on you will go blind looking at your handphone. Okay, so notes is important. You can actually scribble at the side there. Okay, add on to what I explained. Okay, back again to this group 5. Okay, please, I will say later on when I request for assignment, task to submit, don't write using Word because I mentioned no need to use Word, not compulsory. I would prefer handwritten because I will know that this is what student put effort to actually submit. Okay, of course, by drawing out in Word ni pun, it takes time. And I hate using Word to actually draw out block diagram. I hate it because why? It's going to move everywhere, the block. Okay, if I were forced to actually draw a block diagram, I wouldn't draw it in Word, but I will draw it in PowerPoint. Okay, I would never draw it in Word. Okay, because it's too troublesome. Okay, so okay, anyway, I will look at the content. Content is on the actuator system. So you have the motor driver circuit. This group, what paper you got? Encoder, DC brushless motor. Okay, you get the DC brushless motor here. Okay, and then sensor, you have the encoder. Okay, you have the identification. Okay, good. So you have the plus minus, error, input reference here. So input reference, if possible, try to actually put it more to the left side. Okay, and then don't put any blocks lah. Tak perlu block here, tak boleh block this one. Just directly output saja and input reference. Okay, because I already know the paper, so I just want you to understand what was the dish or contents of the paper. Okay, so good in terms of contents, but in terms of the how this group draw the diagram is not correct. Right, so group 5, group 6. Okay. Okay, group 6. Dalini, Muhammad Afiq, Khairul Fahmi. Sama lah ni dengan group 1 tadi Okay, same comment. I will say macam sama ni, you guys copy paste ke ni, and look exactly the same, just tukar warna block diagram ni saja. Okay, not sure, so do not copy paste write it on your own Okay, control architecture, you have this one is not correct. Rotary micro actuator is under actuation Okay, kinetic force. Variable capacitor sensor is actually under measurement system. So I think if you have done this block, okay, never mind. Later on, when we finish up until actuation system, and also on the controller part, so you are going to resubmit this assignment. So after you understand everything, so resubmit means that we have a better version of your assignment. Okay, so group 6. So far, I see that group 3 only is the best so far. Group 3. Okay, this one, group 7. Okay, goggles, CVS, Katiresan. Okay, okay, this one So, okay, let's look at the block. So, what's wrong? Do you think there's anything wrong with the block diagram? Write in the chat. Anything wrong with the block diagram? Okay, arrow. Okay, arrow. Okay, you have the input reference here. Yes. What is this? Okay, arrow. So you have something like this. Actuation system. Ni tak perlu This one no need. You have the controller architecture going into this block. Okay, you have the signal conditioning. Then you go to the actuator. Then you have the output. Right? Then you go to the sensor here. Then sensor, for this student, you have the sensor, flex sensor, and then the, what else? Flex sensor. Flex sensor saja, RH no, that one is on the SB. Flex sensor. Flex sensor saja Okay, so, and then you go back here, feedback. Robotic hand. Okay, what's wrong with that in the chat? What's wrong? The sign? The minus arrow sign? Robotic hand here is not supposed to be here. Robotic hand is actually here. Robotic hand. And robotic hand, you have the DC gear motor, so this is wrong. I think ni no need lah. This one no need. And this XB protocol is actually the signal conditioning. Signal conditioning. So you have the block here. And going to connect to this summation point. Then you have the plus and minus. Don't forget to write out the error. Input reference is in front. Okay. Right. Overall, I think this one is the second best. At least explain it, but some block is incorrect. Group 8. Ahmad Aizad, Amirul Hakim, Nur Khalisa. Okay, journal 8 on electrostatic actuator. Okay. Okay, this one I think similar to journal 3 So you have the output, you have the reference, minus ni atas sikit minus, error, input reference, okay, controller you have here, you have the actuator, electrostatic actuator. Okay, and then you have the sensor, capacity displacement sensor, and also, I'm not sure in this paper, I forgot, but I think there's a 4 sensor here. Then you have the signal conditioning, and then you have this one, right, linearizer, driving signal unit, holding force. Okay, a driving signal unit is under actuation, correct? Holding force is actually the theory behind that driving signal unit. Everything. Linearizer is under the controller. Okay, so need some arrangement on that. 8, 9. Group 9 Oh, and don't forget next time when you submit your group assignment, make sure that put there group number, this is 9 tadi kan, 9. Okay? At least put there group 9 lah, so that I know. Because sometimes when I download lots of things, it's very hard for me to refer back your group what, group 9 ke, and so on. Okay? Nawal, Amirah dengan Safiras So you have the, okay, let's go. What's wrong? You don't have the summation point plus minus. You didn't write error. You have the control architecture. RFID is actually the sensor. RFID is the sensor. Signal conditioning. Okay, you have the DC servo motor is over here. DC servo motor is over here, so it's together. Okay, obstacle avoidance means that what? Proximity or displacement. Okay, not obstacle avoidance. Okay, RFID, signal calculation, DC motor not here. Right, so not so correct lah. Okay. Then 10. Group 10, who are you? who aish. Group 10, who is group 10 I think I have put in an instruction in ULearn. Okay, you need to do what? You need to have the front page. Very, nak cakap lazy pun, memang lazy lah kot. You submit assignment as a group. Right, please write I already put in an instruction. Who are under group 10? What's your name, your matrix ID? Okay. And then, who is group 10? Let me see who's group 10. Group 10. Who's group 10 Okay, Pun, Wong Ging Ing and Wong Wai Jin. Okay, I think you can do much more better than this. One thing is that it doesn't look as like a block diagram, a closed loop block diagram for controller. What you need to do is that I don't know where actually you refer to it. Is this how you draw out a block diagram in the notes that I gave to you? The block diagram has a block. Okay? Okay, do not follow this type of example, but okay, the contents is there. Just that the block diagram is not correct. Okay, it's sorry to say it looks lazy to me for a 3-student work. Okay, for 1 week to settle it, to submit it, you come up with this thing and only 1 page. Sorry to say, but I feel that this is so lazy. Okay, lazy. For me, first impression is that this group do not actually work together, and you do not actually discuss this is correct or not. Is this referring to the notes that the lecturer gave? Okay, first impression is really important. I will remember later on when I mark your assignment or your midterm. If you answer something like this in midterm, diagram 0, even though the content is correct, because you do not understand the concept of block diagram. Okay, so please don't be too lazy to draw out. Okay, don't do that. You are a university student already. You should have done better. If you are working in an industry, you do something like this, they will say, what did you come out with graduate like this? Okay, even drawing block diagram looks like scribbling. Okay, actually. it's lucky that you guys, this one is not assignment that give you marks. This is the reason why I give you some few assignments first before the real assignment come out. Because for the real assignment that I'm not going to give you any comment directly giving marks. So this one is where I will comment so that later on when you submit your assignment, it's going to be perfect. Perfect means that for block diagram is going to be labeled correctly. Okay. So next group is group 11, Lau, Wong, and Shabil. So let's look at the group. So okay, let me understand the group, the block diagram of the group. Okay, if I sekali imbas lah, it's very hard for me to understand this block diagram. Okay, so it doesn't represent exactly similar to what I have shown in the slide. So please make sure that, I think the content is there. Okay, the students trying to explain about the input reference. Okay, correct. You have the control action, controller using PID and so on. Okay, good. And then you have the signal conditioning. But the thing is that this signal conditioning is together with the actuator, right? As the actuation system. So you need to draw it in a block. Okay. And then you have the output going here. And then there's the thing about when you draw out the wrong block diagram. The output is down here. It looks like a feedback to me, okay, because it's going down here and then feedback to the back here, even though it's actually the forward motion. But in one, if I see it in one glance, it looks like a feedback. Okay, so please try to, when next time when you draw a block diagram, try to draw similar to what you have in this block diagram. Okay. Okay, group 11. But other than that, I think the contents is good. Just that the how you draw out the block diagram. Okay, last but not least, let's look at group 12. Group 12. Okay, we have two students, Tang and Madiha. Okay. So what's wrong with this? So let's go to the input first. Input, we have the input reference. Plus, minus is missing. Controller architecture. Actuation, electric pneumatic actuator. And then we have the rotational, so rotation here. Okay, feedback, measurement system. Sensor optical displacement. And then you go to the feedback. Just that, I think you can actually elaborate more on this one. It's too simple. Okay. Okay, right. So I think I have commented on every one task. Okay, hopefully don't take don't feel sad if if I commented that your group is not doing a good job. Take it as an advice to improve your work for next coming task, so that you will focus on doing a better report. Okay, I don't like to have a fancy report, type it out in Word. I prefer just very simple, because this is what is a weekly task. Take out a pen and draw it out. Okay, after draw it out, make a group WhatsApp with three of you guys. Okay, or you can do the voice call using WhatsApp. Okay, and let's discuss. Everybody share their blog. Okay, comment on it. So you just do a three person meeting. And then comment, okay, which one we should use. Okay, if there is, okay, for example, we have each student come up with your own block diagram. Okay, and then we have draft 1, draft 2, and draft 3. Then you guys discuss, okay, which one is the best so far. So for example, the draft number 2 is the best, but the thing is that it's not perfect yet, because lots of missing information. For example, plus minus is not there and so on. So you upgrade on that block. Okay, that is how you actually work together as a group. Okay, not okay. We have tasks. Okay, this week task. Okay, for example, Asfa, you buat for this week. Next week, I'm going to do it. Okay, the next 2 weeks, another student going to submit it. That is not group work. That is delegating somebody to do the task, and you don't actually contribute to anything. And when you don't contribute to anything, means that you do not learn. You don't learn what is the task for this week. Okay, that is the important learning process that I want students to learn when I give a group assignment. If not, might as well I give you an individual assignment. Then I know everybody is actually submitting. Okay? Okay, understood? So if everybody understood, just write in the chat there. Understood or don't understood, or you do not agree, then you just write there why you don't agree. Okay? I'm okay if you don't agree. You explain to me why you don't agree. Okay, all right, so it's already 9. Okay, I will take about roughly 30 minutes. So can we take about 5 minute break if you want to go to toilet, or you want to take a water, drink some water? 5 minutes. We come back. If you see my screen, it's at 9:06. Okay, come back at 9:10. Okay, all right, 9:10. 9:10. Come back in. Okay, we are back. Okay, everybody back? Everybody in? If you're in, then just type yes. If not, I do not know you're in or not in. Okay. Sorry, this is the new norm on online teaching. Because if not, I'm going to be talking to myself. We do not know you are here or not. Okay, and by the way, why 9:10? Because just now I informed you 9:10. I'm actually very punctual. Very punctual in terms of when I say it's 9:10, 9:10, and start class at 8, it's 8. Okay, because last time I was studying in Japan 5 years, so being punctual is really important. Why? Because you don't actually waste other person time while waiting. Okay, so this morning is was very good. Okay, so now I'm going to continue with chapter 2. Which is on sensor and transducer. Okay, so for this topic is that we are going to cover LO1, okay, LO1, okay, and LO2. So L1 is that basic concept of macro system. So basically it's on the measurement system lah. Measurement system. And then explain the working principle of mechatronics. So when you talk about working principle of mechatronics, is basically the working principle of the sensor or transducer. Okay, so after completing this lecture, which is chapter 2, is that you are able to explain the sensor performance terminology, categorize different type of sensor, its measured quantity, and the sensor operating principle. So what are the principle? Example, displacement sensor, encoder, what is the principle? The potentiometer, what is the principle of operation? And the third one is that select the suitable sensor for different type of measurement. So if you are going to measure a force, so are you going to use what type of sensor are you going to use? Are you going to use an encoder? Is that the correct sensor to be used? So this is where you learn which type of sensor is suitable, because later on this knowledge is important when you apply to the IDP project. So what is IDP? Anyone know what is IDP? What is IDP? IDP. What is IDP? What is FYP? You can type in the chat. What is IDP? What is FYP? Anyone? If you don't know, just say no. I don't know. Okay, FYP, Wang Weijin. Okay, FYP is final year project. Okay, good. Final year project. So what is IDP? What is IDP? You should have heard about it now, up until now, because you are a second year student. You are going to do IDP next semester. Not semester. You are going to do IDP during semester year 3, semester 2. Okay, Aiman jawab, indirect project, no. What is IDP? IDP is integrated, it's not integrated design project. Okay, integrated design project. Previously, this was known as a subject. Okay, this is a subject, IDP is a subject. And before this, IDP was known as mechatronic design project. Okay, so we have actually changed it according to the EAC. So we changed it to integrated design project. So IDP is actually a group work. You're going to take a subject and then some explanation on the theory, but it's going to be fully group work and coursework. So one group will have 5 students inside. Okay, so this is where you learn about designing a mechatronic project. So in this mechatronic project, you learn which sensor is suitable, which type of actuator is used, what type of signal conditioning that you're going to use, and then what type of controller if you need to have a controller. Okay, so this is where you start to learn about designing a mechatronic project or mechatronic system, but as a group. Okay, and then this one will be on the 3rd year. second sem. Okay, final year project is where you start to do your final project in the fourth year, first semester and second semester. Okay, and this final year project is individual project. Means that you're all alone, but you have a supervisor to supervise you. So similar to IDP project here, you also have a supervisor. So like me last time, I have normally for each supervisor we have one IDP group student, and then for final year project for mechatronics, we supervise up to 5 students per batch. So right now for this semester, I have 5 students for final year project. IDP not yet. Next semester that I will have one group lah for IDP. Okay. So remember, everything that you are learning in this subject, which is Introduction to Mechatronics, is really important later when you are going to apply it to the IDP and FYP. Trust me lah, because why? Later on, I'm going to be your supervisor later on for your IDP or FYP. I'm going to ask you guys, okay, what type of sensor or what type of actuator you plan to use? Okay, then the student can explain, okay, what type of mechanical system? Ball screw. I mentioned, okay, what type of actuation that you can use to convert from rotary to linear actuation? Student cannot answer, and then I will ask them, you have learned this in Introduction to Mechatronics. How can you not explain what type of actuator that can be used? Because there are lots of mechanical actuator that can be used to convert from rotary to linear. One way is ball screw is one example. Okay, so this is where I will see which student can still remember what they have learned in the subject Introduction to Mechatronics. Yeah, it's only one gap of one year. You shouldn't have forgotten about the topic. Okay, so this is why you need to learn or focus on this part. It looks simple, Introduction to Mechatronics, 2 credit hours. Simple, but if you do not understand the contents, you have trouble later on when you go for your IDP. And IDP maybe no, because it's a group work, but you have trouble when you do your final year project. Okay, so let's recap on the mechanical control system. So I have explained that you have the input reference. Input reference is normally the reference value, and it should be the same with what you have as the output value. So if the output is the one that you want to control is actually, is the angle, then the reference here should be angle also. If the output is in displacement millimeter, then you have the reference here is also in millimeter. So if it's a block diagram, a closed loop block diagram, then the reference input and output should have the same measurement, okay, value, yeah, or not same measurement, the same unit, same unit. Okay, and remember, the whole thing here that you see in this block, the whole system is actually, we call it as the control block. Control block for mechanical system, or we call it as a control system, block system, closed loop block system. And under the closed control block system, you have the controller architecture. Okay, then you have the actuation system here, over here, and the actuation system, normally you have the actuator plus the signal conditioning. This is together. Actuator cannot work without the signal conditioning, so it must have the signal conditioning interface. Okay, where you are going to convert from D to A, digital to analog, and digital to digital signal. And from here, from the actuator, normally if you have a hydraulic, pneumatic, or electrical, okay, this motion actuator, if we talk about mechatronic, most of the time is going to be a rotary type. If we talk about displacement, measurement, so we have a rotary, the main one, and the linear. Okay, of course you can have actuator like, for example, thermometer. You are in the temperature, can, the measurement is temperature and so on. So This is where you have the actuator, means that the reading output here will be a rotary, linear. Rotary means that in degree, or linear in millimeter or cm, and temperature in degree Celsius. And this one you're going to output. So you can see that when you have a rotary rotation, then you can see that the motor is rotating. But can you actually get the data if you do not have a sensor? Okay, you give an input. For example, I think most of you know how to use Arduino by now. So you have an Arduino, you give a signal to the motor, DC motor, you give a signal to DC motor, voltage signal. What happens that the motor going to move? But most of the motor, the DC motor do not have a sensor, which is, we call it as an encoder. You don't have that sensor. So when you don't have that sensor, you can only see that the motor is going to rotate, but you do not know what is the rotation angle. Is it 10 degree? Is it 25 degree? Is it 60 degree? So this is where you need to have the reading, the sensor here. Sensor here is to read what is the measurement. Okay, so you can have the encoder for the displacement vision if you have a camera attached to the actuator. So you have a vision to actually collect the data, and force to measure the load cell to measure the force. Okay, and for measurement system, it's similar to like the actuation. You need to have the signal conditioning also similar to this. So it's going to cover from analog to digital and digital to digital. Okay, and from here is that, so basically this output, if you see this output going out, okay, the sorry, the arrow here, okay, this output I star here is actually the same thing as here, just that this one is the one that is not being measured. This is the one that is being measured, and you know what is the value. So we take an example of the displacement just now in millimeter. So when you read, for example, you have the reference that you set is 10 millimeter. Okay, and you read here the displacement is 9.5 millimeter in 9.5. Okay, so means that because you have the sensor, then you know, oh, okay, the actuator actually moved 9.5 millimeter. Okay, after going through the sensor reading and so on, okay, come up with 9 mm. So 9 mm here is going to go to the summation point here. So we have 10 minus 9.5. So means the error is 0.5 mm. So because of this, when the control architecture detect that there is a value in the error, then this controller will actually adjust so that you can actually we control the system so that it will actually make the error smaller. Okay, it depends on what type of controller you use. PID is the common one, conventional controller. Okay, or you can use fuzzy logic for the AI, artificial intelligence, and so on. Okay, so after doing the controller part, it's going to reduce the error, and then go back into this one, signal conditioning, and give the signal to the actuator to move it accordingly. Then you see that, oh, okay, next it goes to 9.9 mm. So 9.9 is good. 9.9 mm. Okay, it's already error is 0.1 mm. Okay, so it's good enough. So is this if we think that the controller is good, then with 0.1 millimeter error, then you can actually decide that your developed controller is sufficient or suitable up to that point. Okay, so explaining one slide pun take long for me lah, because normally I will elaborate. Okay, let's go to this slide. So back again, so just now I will explain it for the whole block. So right now I'm going to explain what is sensor. So sensor is what? So sensor are defined as a device which is used to measure, so based on what I explained just now, so it is used to measure physical quality, for example, light, sound, temperature, or it can be displacement. Okay, displacement can be in linear, millimeter, centimeter, meter, or in rotary degree, in rotary degree or radian. Okay, so sensor give the output in an easy to read format for the user. So normally is that you want to see that because if you do not have sensor, like I said in the previous slide, you cannot actually see what type of reading that is going to give. For example, in displacement, is it 10 mm? You can look with using your eye. Oh, okay, it's moving 10 mm, but are you sure it's 10 mm? Okay, so that's why you need the sensor, especially when you have a very precise motion, like in millimeter or micrometer. So you cannot rely on your eye. You need to have a sensor to read that. Example is mercury thermometer. So mercury example is an example of simple sensor where when the temperature rises to give reading for user, there are no electrical intervals or changes. So it means that mercury thermometer the normal thermometer is that when you measure, you put for example those with fever, you put in your tongue, under your tongue, then what happens there is going to give you directly the temperature. There's no electric signal that you have to use for that reading. So this is what you call by sensor. Okay, and so what is transducer? So you might find out, hey, so why it's called for the topic for this chapter, sensor and transducer. Okay, so what is transducer? Transducer is can measure similar quality to a sensor. Okay, so it's actually the same thing, but will convert signal from one physical form to another, meaning the input and output signal are not the same of each other. So it means that it's going to convert measurement into electrical signal. So this is what commonly used sensor in mechatronic system is about. Okay, so basically, if you want to use the term, it's better to use the term transducer. Okay, but if you use sensor, it's acceptable. We in mechatronic, if you say that you are using this type of sensor, blah blah blah, and so on, we will understand that it's actually transducer, because for transducer is that it's going to convert from the reading. Because if you remember the previous block diagram here, this sensor, you're going to actually convert it into electrical signal. Okay, so this is where it's actually with combination of the conditions, signal conditioning, it become a transducer. Okay, so example, there are types of transducer. So there are input transducer and output transducer. So input transducer takes a form of energy and convert it into electrical signal. For example, form of energy is what? Form of energy is force, displacement, and convert into electrical signal. So we have the principle of operation of that transducer. So it's going to convert from the measurement, the measured data, displacement, to electric system, which is what is electrical system? Is a reading that the sensor can read. So it's in voltage normally, voltage. For example, like Arduino and Microbox, it can read from 0 to 10 volts. So this is where what it means by input transducer. Output transducer is it takes electricity and convert it into other form of energy. So it means that it convert from electrical to electricity to energy. So for example, it's light bulb. Okay, convert electric to light. Good. So we call this SOS transducer. Okay, or motor converting electrical to motion. Okay, so there are few types. 30 more minutes. So there are many types of measurement systems. So you have force, motion, temperature, pressure, flow, etc. So all of this is our physical quantity. So we call this as this is physical quantity that can be measured using sensor. And this sensor combining with the signal conditioning, then you will have a complete system, which is called the transducer. Okay, and normally when you have a sensor, you want it to have a feedback to a controller if you want to control it, or you want to just display it. Okay, display means that you want to see the reading. Okay, so this one, okay, just skip it, just a recap. Okay, from this block diagram, okay, let me just simplify the block diagram. Okay, so block diagram, you have input reference, controller, actuation system. Then you have the output here, feedback to the measurement system. So we are now talking about this measurement system. This is how in this chapter, the chapter 1, I explain the block in this way. But you can also later on when you learn controller, you will learn that okay, actually measurement system can also be written into this type of block. Means that controller, actuation system, and actually actuation system is linked to the sensor to read the data. So you have the measurement systems, because here is where you have the sensor and you have the display. So you can display the output here. Okay, and this output is the one that going to feed back to the input reference. So this is the two ways how to actually write out a block diagram, closed loop block diagram. I would prefer that student use the second method, because this one second method normally in IDP and final project, your lecturer will refer to the second method. Okay, and under the measurement system, okay, you have the quantity being measured just now. You have the force, you have the displacement, you have the temperature. So then it's being read by the sensor or transducer, and then it's going to go into the signal conditioning. And then of course, because of this, most of the time you need to have a data representation. So data presentation system, later in chapter 4, you are going to learn this. So signal conditioning, you are going to learn it in chapter 3. This one is chapter 4. Okay, and this is where the value of the quantity is going to be displayed. Okay, so either way, this one, remember this represent this block. So means that this value of quantity is at the end here. So it's going to feed back to the reference. So what are the principles for measurement? So I think this one is general. I think you can read it on your own. So process being measured, the input is being measured by the system, then going to give you an output, and observer is normally is the display. Okay, this display. So and normally the input measurement is true value lah. So sometimes when you have obstacle avoidance sensor, you want either 0 or 1. Means that if it 0 means that it doesn't detect any obstacle. If it's 1, it detect obstacle. So this is what it means. Okay, this one is just fast one. So signal conditioning element, what it means that it takes output from the sensor and convert it into form suitable for processing. So normally if you do not have this signal conditioning, lots of the signal that is read from the sensor is going to have a noise, okay, high noise. So that is where you need to have a filter to filter out, low pass filter or second order filter or first order filter. So you add a filter. Or sometimes the reading from the sensor is very small, too small. So you need to amplify it. So that's why you need to have the amplifier. So this is what it means. You need to have a signal conditioning. Okay. And then second one is that signal processing element. So takes output from the signal conditioner. So from this one, it's going to take this signal and perform analysis transformation. So the easiest way is that you have the A to D and D to A converter. So A to D is what? It means analog to digital. Analog to digital. So analog means that a signal in analog. If you have learned signal system? Yeah. I think no. You will learn signal system in second year, second sem, I think. So and in A to D, analog to digital is that you're going to convert from analog signal to digital. Analog means that you have a continuous signal. Okay, so it means that a reading from if I have a sensor that going to sense my heartbeat, so it's going to give a continuous signal. So that it means by analog. But because we want to process that signal, so we need to convert it to digital signal that can be read by the machine or by your computer. So that what it means by converting from analog signal to a digital signal. And another one is that D to A. So D to A is converting from digital to analog. So where do you actually see this analog to digital? So let's look at this block. Okay, so most of the time is that you see that the output here is the physical quantity, kan? So it means that just now that my heartbeat, okay, it can be read here in the graph. So this graph is in terms of analog signal. So that's why because this signal is going to be fed to the controller, which is your PC or your laptop. So means that you need to convert this A to digital. That is why you have the analog to digital. And vice versa, when you have this digital, okay, this digital up until here will be digital signal. Then it's going, because your actuator can only read in terms of analog. So you're going to convert from digital to analog here. So the operating, the signal conditioning will be D to A interface. Okay, so this is where you use the analog to digital. And the third one is that the data presentation. So example, you want to have a computer to display it, you want to have a graph, plot it directly, real time. And then you have the indicator or gauge and so on. So this is where you have the data presentation. So why do you need to convert physical phenomena into electrical system? Because all of your equipment are using microprocessor. So example, you are using Arduino just now, or Raspberry Pi or Microbox. So all of these are microprocessor that can only read digital. Okay, so you need to have these signal conditioning elements and so on. Okay. So this one is, I think I skipped this one. This is one same thing. So you have the input sense element, and then you have the signal conditioning, then you have the processing element and data presentation. Same thing. So I skipped that. Sensor in controller. So it's this one maybe not a good block diagram. So not comparison, but a comparison block is okay if you want to put the comparison. You know that you are going to compare, but I prefer that you put the summation point. So summation point. So this one is the closed loop, like I explained previously. Okay, so now we are going to go to the sensor definition terminology. Means that under sensor there are two performance, which is the static characteristic, which are the value given when steady state condition occur. And this is after the sensor has settled down after receiving input. And second one is that dynamic characteristic, which is referred to behavior of the sensor in transient condition. Okay, so in terms of terminology of the static characteristic, so you are going to learn 11 terms. I'm going to go very fast to explain this. Later on, you have a table to actually do some individual work and to submit it. So let's go to the first one on range and span. Okay, range and span. So what does it mean by range? Range is the range of transducer defined by the limit between which the input can vary. Okay, the span is the maximum value of input minus the minimum. Okay, blah blah blah. What does it mean? So meaning that if you have a load cell, okay, load cell is actually an example of force sensor. Okay, so it's going to measure, if you see here, the force sensor. For example, I have one force sensor in the lab, and it's going to measure between 0 to 50 kilonewton. So this is what we call as the range. The range of the sensor, it can read between 0 to 50 kilonewton. Sometimes there are a sense, okay, this is range. For example, force. I give you an example of displacement sensor. Okay, the range is given by 0 to 20 millimeter. Very small, because this is a precision sensor. So we have the range for displacement is 0 to 20 millimeters. Sometimes there are sensors that actually can read from minus 20 to 20 millimeter. Means that minus plus minus lah. Plus minus 20 millimeter. Okay, so it depends on the type of sensor. Of course, if you were to purchase between these two sensors, the bottom sensor much more expensive lah, because it's double out the span. Okay, so that is what we call as range. For span is actually the maximum value of the input. So if we refer back to this force sensor, so what is the span? Span is actually the maximum minus the minimum. So the span here is 50 kilonewton. Sorry. 50 kilonewton. 50 kilonewton. For the displacement, for the second one here, displacement, continue down here, is the span is 20 millimeter. Second displacement is 40 millimeter. Okay, so that's the span for this type of sensor. Okay, or we can go see another example of thermocouple. So thermocouple, the input range is between 100 to 250 degrees Celsius. Okay, so it means that you have the range between the range is this one, and then you have the span is 150. This is the span 150 degree Celsius. Okay, so error. Second one is error. So error is the difference between the measured and true value of the quantity measured. So this one, I think you already know this. This one is from the block diagram. So measured quantity minus the true quantity means, I think is wrong as true value minus measured value. So for example, if this is changed, so you have here 26 minus 25, you have 1 degree. Okay, so error, if you look back at the control block, you actually have the reference error minus the measured error. Okay. Okay, this one I just give you an exercise, but you can do this at home. Draw the closed loop block diagram and label each parameter. Just a recap if you can draw it out. Okay, accuracy. So accuracy is mean that as the largest expected error between actual and ideal output. Sometimes it's called the extraction of full scale. So accuracy is something that measured the difference between measured and actual value. So it's similar to error. So but if you are doing controller design for control performance, you want to look at the accuracy of the sensor. So is the sensor going to give you exactly, if the range is 0 to 20 what, okay, 0 to 20 Celsius, okay, is it going to give you directly maximum 20 degree? Okay, so maybe no, because for sensor, it's actually a device, so it's going to give you plus minus accuracy means that it can give you between 18 degree or 22 degree, even though in the lab sheet it tell you that it's 20 degree. So this is what it mean by accuracy. So accuracy is defined by the company, the data sheet. Okay, or you can directly ask the company what is the accuracy of the fabrication. So fabrication, for example, plus minus in millimeter or in micrometer. Okay, so this one is same thing. So sensitivity is defined as the relation between input physical signal and output signal. So it means that generally a ratio between small signal in electric signal will give small changes in physical signal. So example is that if let's say a thermometer would have high sensitivity, if a small temperature change resulting in a large voltage change, means that small change in the temperature give a large voltage change, then it means by high sensitivity. If small changes in temperature give you a small voltage only, then it's low sensitivity, not sensitive enough. So how do you actually can get the sensitivity of the sensor? How do you calculate this? So let's look at this graph. So let's say that you have the equation y equal to mx to find out this one. So let's say that c is 0 because it's at the center here. So you have m is y over x. Okay, so m here is actually referring to the sensitivity. So y is this value and x is this value. Okay, so it means that if you have a more steeper slope, then it's high sensitivity. If it's low slope, then it's low sensitivity. This is high sensitivity, this is low sensitivity. Okay, so meaning that you can actually refer to data sheet and calculate if it's have high or low sensitivity. And next is hysteresis error. So some sensors do not return to the same output value when the input stimulus is cycled up and down. Meaning that at this case is that input, if you give a signal or the value, temperature value, for example, now is temperature. I don't want to give a temperature. I'm going to give you a displacement value. So displacement value, we start at 0 normally, displacement. You are going to give a signal Okay, going to give a signal, the step input signal. Okay, 10 volt. So it's going to go up 10 volt. So what happens that the displacement will start at 0 here. Okay, 0, and then it's going to go up, move up. Okay, so meaning that supposedly if the sensor is linear value, then it's going to read a linear graph. But in some cases, some sensor do not give you a linear graph. It's going to give you an increasing graph like this, a slope. And then when you return back, you give the opposite signal, it's going to return back in a different direction. So if this happen means that we have a hysteresis error. Okay, if when you test a sensor, you give a sensor like, for example, like this, it give you a linear for this increasing motion, and then it's going to give you a linear in when decreasing, then you say that there's no hysteresis error. Okay, so it means that hysteresis error is the maximum difference output between the increasing and decreasing value. And you can see the example of this graph here. So you see that the increasing value is the one, okay, velocity rise. We set the blue one, so it's going to go up here, and then voltage drop is the other way around. So where you can see that there's a hysteresis error there. Okay, next is nonlinearity. So nonlinearity is something that similar to what I explained just now. If you understand what is linear, means that when you give an input, it's going to give a linear output. Okay, and when we talk about nonlinearity, means that when you give a linear input like this, you are going to have a nonlinear output. So this is what we call as nonlinearity. Okay, so you can see that this one example. So you have a nonlinear output, and nonlinear output. So this one is we call it as the nonlinearity. Okay, very fast. Repeatability is something that the ability to produce the output signal exactly when the same measurement input is applied in the same environment. So this one is example. If you were to test out the sensor, okay, normally I will ask student, okay, do the testing of repeatability for sensor, for this temperature sensor, do 10 times repeatability. Okay, check it using the same input value. So when they test out, they are going to get 20 degree every time, 20 degree, 21 degree, 20 degree, and so on. So it means that if it's actually produce the small percentage here out of the full scale value, then means that the sensor is good in terms of repeatability. Means that to produce the exact output with the same input. Okay, so you will want a sensor that can be able to actually repeat the same signal using the same input. Okay, you do not want to buy a sensor which is not stable. Every time you check, it's different output. Okay, stability is something that ability to give the same output when used to measure a constant input over a period of time. So you see here, repeatability and stability is almost the same, just that it is that if you apply a signal over a long period of time, instead of applying for 1 minute, you apply it until 60 minutes. So is the reading going to be stable value, or is it going to go up and down, and so on? Okay, so this is what it means by stability. So it means that the measure a constant input over a period of time. Okay, next is deadband time. So deadband value is the sensor in the range of input where there is no output. So normally when you read a reading of the sensor, you can actually get a data everywhere. But somehow in between this value, there's no data. So this is what we call as the deadband. Okay. So next is resolution. So resolution is important to when you find a suitable sensor. So you want to see what is the smallest increment in the measure output. Okay, example temperature sensor. So you check what is the data sheet. If you say that resolution is 0.01 degree, so this is very good. But if you check a data sheet, if it say that the resolution is 1 degree, which one you want to buy? If I were you, I want to buy a smaller resolution. Okay, sensor. So of course, by having a smaller resolution sensor, in that it's going to be more expensive. Okay, so in the end you need to look at your budget. And lastly is the output impedance. When a sensor gives electrical output interface, so basically the output maybe will be connected to either serial or parallel circuit. Okay, this is where you will need to check how do you actually assemble your sensor to the actuator. If it's in series or parallel, you need to check either the output impedance need to be adjust accordingly. Okay, so for more information, you can just read out what our input impedance and so on. You can go through the books, the textbook that I share to you. Okay, find it online. It's online. So this one will be the individual task. Okay, individual task, read through. So create table listing all 11 performance and terminology and the explanations. Student may refer to textbook, reference book, and website. Use the template provided. Okay, study student data sheet. Study data sheet to understand sensor performance. So I have uploaded the data sheet in ULearn D1 until D2. So this one is not a group assignment, but when you do this assignment, please for each student refer to the data sheet numbering. So for example, you are under group 1. So for group 1 student, you refer to D1. Okay, for group 4 student refer to D4 and so on lah. So refer to that. Okay, compulsory next week is the deadline. So this one is example of how you need to write into a table. Okay, range based on your data sheet. Okay, range until 11 output impedance. So what definition, the figure that you can find in there, or additional one that you need to refer to textbook. So do not only refer to the data sheet to do this exercise. Equation involved, if any, and example where you can actually use the sensor. Okay, so this one I give you one example, but do not copy this one. Okay, example is already in the ULearn. And then I think okay, this one static and dynamic you can read on your own. Try to read it on your own. I think this is straightforward, response time and so on. Okay, you can read that one and then try to answer this question. So what is the steady state value? What is the response? Answer it. Okay, and then this one are the three main factors. So you can see that required measurement, output requirement, and performance. So you can see system performance is the terminology that we use, accuracy, range, and so on. Okay, and final selection, it depends on what I have list out here: size, type, what type of sensor that you want to use, resolution, accuracy, material to measure, and cost within budget. Okay, so you can read through this one I already explained just now. Okay, so this one is a quick question. Which one do you think is the actuator and which one is sensor? So I give you the answer directly. So A is actually the actuator and B is the sensor, okay, which is the encoder to read the rotation here. Okay, this one is the setup. You can try to understand it. Okay, I just want to show to you okay, this one, exercise 2 and exercise 3, okay, which is a group exercise. So in the group, discuss the following tasks by referring to slide 59 and 88. So go through the slide. Okay, so what you need to do is that for the following measurement system, fill in the template. So you have 9 types of sensor. This is a group work. Okay, displacement, proximity, velocity, force, fluid, liquids, flow, liquid level, temperature, and light. Okay, based all compulsory to answer. Not select one, but all need to answer it. Okay, as a group. List 2 examples for each input device's sensor and explain its working range using diagram. Give an example of output device. So use this template that I have give to you an example. Of course, this one is an example of position sensor. For position sensor, I said 2 examples, which is position sensor. They are first one you can take increment encoder and potentiometer. So explain output devices that can be connected to this encoder. So example here, I put here motor. If you think that there are other things that you can put here, so you use this here. Okay, potentiometer, where you can use this. Theory of operation of encoder. So explain it, blah, 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 blah. Diagram of operation. So example, I show to you example of potentiometer diagram of operation. So basically, this diagram of operation need to be explained with the theory. So this theory explaining the diagram. So this is example 1, but you're going to submit 1 until 9, and each of these is 2 types of example sensor, specific sensor. And another group task that you're going to need to do submit this week is which is next week, exercise 3. Okay, example of Mercury project. So read through. So the task is actually based on this is that you have to have task line following. So straight line and curve line. Okay, object obstacle avoidance. So the robot need to avoid this obstacle. So how it's going to avoid and so on. So the question here is that task 1 for obstacle avoidance sensor, what type of candidates that of sensor you can use? Is it positive sensor or positive sensor and so on? So list it out. Please select the base sensor for the task and explain the reason why the sensor was selected. For example, if you choose proximity position sensor, ultrasonic sensor example, so how many sensors are required for each task? What do you think? For example, for the line following, okay, if you say that ultrasonic sensor, so where are you going to put the sensor? At the side here? At the front here? How many sensors you want to use? At least minimum 5 or only 1 is enough. So this one I want student to discuss as a group. So based on question 1 just now, based on question 1, which is this one, okay, assign the base location to mount the sensor and explain your reason. Draw the front view, side view, and support your answer. So when you draw it, make sure you label everything. Okay. So I think that's all. Every task, exercise 1 individual, exercise 2 and 3 is group. The deadline is next week. It means that next Wednesday. So I give you ample time to do that. Okay. So this one is 59 until the end. You need to refer back to this task exercise 2. So I think that's all. It's already 10. Any question? Any question? You can just unmute. I think that's all. If you can complete this task. By the way, I just show to you the ULearn. Okay, the task I have update in ULearn. So you are here. Okay, submit task. As per Webex instruction, submit exercise 1 as individual task. So submit it here, individual task. Self-study on slide 59 until 88 and answer exercise 2 and 3. So exercise 2 and 3 here, and exercise 2 and 3 you need to submit separately, 2 files. Exercise 2 group 1 example, label it as file group 1 and group exercise 3 group 1 example. Okay, and datasheet is inside here. Okay, example datasheet. Okay, for group 1 and group 7, refer to Dasel datasheet here. Group 2 and group 8 refer to this one. So it's everything is in ULearn. So any question? I think you have class. So I'm not going to take any more question, any more of your time. Any question? No? Pardon. Pardon me, doctor, how to change profile picture on Webex. Profile picture, you need to log out and then log in again. You know how you set your Webex? You need to log in to webex.com. Okay? Go to webex.com, log in into the online Webex. Okay? Do not log in using your apps. Apps, handphone cannot actually set it. You need to use computer to set it. Go to Webex. Okay, I just show you a demo. Can you see my screen? Okay, Webex. Example, this is Webex. Go to webex.com. Okay, webex.com. Okay, and then you already sign up because you already have your name. So webex.com. For my case is that I log in using my email. So my email time.edu.my. Okay. Okay, inside here, your Webex. If you see, this is my Webex. So you click here because you don't have photo. So I have already photo. So you click here, change. You change here, then you click on this photo and upload photo. Okay, so normal upload lah. So use online. Don't, I think you can use your handphone. Just you need to write there www.webex.com. Okay, same thing. Right? Okay, alright. So, okay, Aiman. Alright, any more question? Okay, if no, then thank you very much. Sorry I took too long. I said 1 hour, but it's already 2 hours. So, next class will be on this Friday, and I will be covering just a little bit lah because chapter 3 will be on signal condition. Signal condition is is not that long, so I'm going to cover it. Let's see. I'm not sure if I'm going to do synchronous class. Most probably, I'm going to do a synchronous class. So anything I will update in Ulearn. So that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye.